What's up guys, in this video I thought of making a video of a very interesting thing I learned today, and that thing was what if we nest two or three or more than three loops together, and what will be the value of k. So for example, right here this is the question. So it's asking us that what is the value of k after the following code executes, where n1, n2, and nm are positive integers. This code has been executed. So first they have taken the value of k, that is 0. So the initial value of k is 0, and for i1 means so you can say that for the parent loop they have set I equals 1 up to n1, and n1 is any positive integer, and then they have nested the second loop after the first loop. So the first nested loop is I2. So for I2 that is also equal to 1, and it will execute up till n2, that is also a positive integer, and the process goes on up till the last loop, means you can say the most so you can say the most traversed loop, that is for im. So im is going to be the last nested loop, and that is also equal to 1, and that will execute up till nm, that is also an integer value. And in that last loop you have k, and you have a statement that is k equals k plus 1. So they are asking us what will be the value of k after this code execute. So instead of m, we can take any integer value. For example, we can nest 5 loops or 6 loops. In this video, for this video, I'll nest 3 loops. So in order to show you guys how this works and how the nesting of more than 2 or 3 loops actually work. So let's first declare our variable that was int k, and let's set it equal to 0. So 0 will be its initial value. Then what we are going to do is we are going to make 3 loops, means the parent loop and then 2 nested loop inside this for loop. Inside this for loop we are going to declare I, that is also equal to 0, and the condition is I is less than or equal to, and for n you can take any positive integer. So let's say 6. That is an arbitrary number or arbitrary integer. And then I plus plus is, we are going to increment I, and then the statement instead of a statement I'm going to include another for loop. So there is also int I equals 0, the same thing. And then for the condition I is less than or equal to, let's say 3, and I'm going to increment I by 1. And then again, instead of a statement, I'm going to write int I equals 1, and for the condition, let's say up till I is less than or equal to, let's say 4, and then I'm also going to increment I by 1. So let's actually do 4 loops instead of 3 loops, so it can get a little bit more exciting if we will do 4 loops instead of 3 loops. So that'll make it a little complex to understand, but at the end it will give us clean satisfaction of how this works and how easy it is, and how much difficult we thought it was, but it isn't as much of a difficult concept to understand as we think it is. So int I equals 0 again, for condition I is less than or equal to, so here let's say 7. Oh yep, let's say 7, and I'm going to increment I by 1, and inside this statement the statement is going to be k equals k plus 1, or you can just simply use this operator that is a shortcut. So k plus equals 1. This also means the same thing. So this means that k equals k plus 1. So this is just a short form of writing that whole thing. So what is the value of k after this loop, after all of these loops? Means after the first loop, the second, the nested loop, the third, and the fourth. So after all of these loops execute, what is going to be the value of k? Well, let's run this program and find out, and then I'll explain how it worked and why it showed this value of k. Alright, so first I'll also have to see out the value of k as well. So see out k, and so let's see what happens. It is showing me 896. So 896 is the value of k. So now let me explain why it did that and why is the value of k 896. So here, so all of this happened due to product rule, which I studied lately in discrete mathematics, and it's pretty interesting as well. So if you guys look here, so this is right here is the explanation. The initial value of k is 0, as it's self-explanatory. The initial value of k, I set it to 0 each time the nested loop is traversed. So traverse means travel across. So traverse means it transfers to the next loop. So for example, from this loop it transfers to this loop, and from this loop it transfers to this loop. But each time the nested loop, so each time, so they're talking about this loop right here, the last loop. So each time this loop is traversed means this loop is executed or travel across. 1 is added to k, so k is incremented by 1 after each time this loop is traversed. Let ti be the task of traversing the ith loop. So let ti means it's be the task of traversing the ith loop. So what is the ith loop? So this is all of these loops are ith loop actually. Traversing the ith loop, then the number of times the loop is traversed is the number of ways to do the task. So all of these loops are ith loops. So each time a loop is traversed, we will consider it to be we will consider a task to be done each time a loop is traversed, each time the ith loop is traversed. So then the number of times the loop is traversed is the number of ways to do the tasks t1, t2, and up to tm. The number of ways to carry out the task tj means each individual task. The number of ways to carry out each individual task tj, where j equals 1, 2 up to m, is nj, because these integers means these conditions, that is nj. So each time this loop is going, all of each individual loop is going to be traversed up till the value that we have assigned right here, that is 6, 3, 4, and 7. So that is nj. Because the jth loop is traversed, so jth loop means that they're talking about each individual loop. So because the jth loop is traversed once for each integer, so so every loop here, for example, let's say they're talking about this one, so this loop is traversed means this loop is executed once for each value of I until this value of I is greater than 3. Once for each each integer ij, with ij greater than or equal to 1 obviously, and less than or equal to nj, by the product rule. So what the product rule says, it follows that the nested loop is traversed n into n2 into up till nm times, hence the final value of k is n1, n2, nm. And product rule here, if I scroll up, the product rule says that suppose that a procedure can be broken down into a sequence of 2 tasks. If there are n1 ways to do the first task, so for example this right here is the first task, and there is n1 means there's 6 ways to do the first task, and for each of these 6 ways, each of these 6 ways of doing the first means each of these 6 ways that there are n2 ways to do the second task. So there are, for example, there's 3 ways to do another task, then there are n1 into n2 ways to do the procedure, and successively if we solve for the product rule in this case, it gives us 6 into 3 into 4 into 7, and that gives us 896. And I can prove it by opening the calculator. And what I'm going to do is I'm going to plot the values, that is 6 into 3 into 4 and into 7, and that is alright. So why is it not giving? Alright, so it's giving me the wrong answer actually. 6 into 3 into 4 into 7, it's giving me 504, but this is actually equal to 896. What have I done wrong here? Alright, so actually we have, so this is the mistake I've done. We had to set I equal to 1 in every loop, and that is why I was having that error. So you see what I did wrong there? I set the value of I in 3 of these loops, that was equal to 0, and if I run this loop right now, it's giving me 504, and indeed 6 into 3 into 4 into 7 is indeed 504, which proves that product rule is very valid. Alright guys, thank you very much. I'll see you guys in the next video. Until then, goodbye.